All right, students, last lesson of the year. All right. I will be able to identify how constructive and destructive forces shape the Earth's surface and distinguish landscape features based on geologic processes or processes. Launch for today. What is one landform you've seen? For example, mountain, valley, beach, canyon. Describe how you think it formed. Then think of that landform, how it was created by something that was built up, broken down, or both, and why. All right, so mountains. In order to make mountains, that's your orogenes, right? That's the word that we use on the reference table, mountain building events. You have to have plate motions, and these plate motions will be your converging plate boundaries, right? In which the overriding plate or the uplifting plate will begin to crunch together and be built up, right? Making a mountainous landscape. So these rocks can break. They can get faulted. These rocks may not break. They may get folded. All right, and some of these rocks can, be, like I said, crunched up and have high elevations. All right, and that is definitely the building up. Valleys are your low areas. In which you have, in between, two peaks, you have your valley. All water flows in valleys. You have your tributaries that will contribute to the overall volume of the main tributary, which is going to be your river within there, the main portion of it. You may have your brooks and your creeks and your streams all leading into probably the main branch of the river. All right, and within these river systems, you're going to have parts that are going to erode, which is going to be breaking it down, right, or broke it down. And there's going to be parts where it gets deposited, in which you're going to build things up again. So valleys, for the most part, depending on where it is, if you have valleys at high elevations, it's going to erode more. It's going to be broken down. But if your valleys are near the oceans, at lowlands and flat plains, it's going to deposit. It's going to be built up. Beaches, that's going to be the last portion. The mouth of rivers, the mouth of the sheet flow that happens, and that's where all of your sand grains will develop. That's going to be your most resistant minerals. They don't break down that much. And for beach sand is mostly made up of quartz. Quartz has a hardness of 7 on your reference table, and that is a very resistant mineral for weathering and breakdown. But they can be transported, so it definitely will erode. It will be broken down through wave action, and until you build a rock groin or rock jetty in which it can get deposited, in which it can be built up. So at the beaches, it can be both. Canyons, last example here, Grand Canyon I can think of. Grand Canyon was once all straight land. You can walk across it, no problem. And then it all began with a small little channel, and that channel became deeper and deeper and deeper, right? There is a evolution of becoming a canyon. Gullies are one of them, in which you have a pretty wide area between two portions of land separated by a channel. All right, so canyons, we're dealing with, canyons are uplifted rocks, right? So that can be built up. And then if you have running water in that canyon, of course, because canyons have to have a gap between land masses, there's going to be erosion and deposition, right? It can be both. All right, landscapes. Here we go. Landscapes have similar geologic structure, elevation, and slope or gradient. Examples include, we have mountains. high elevation landforms with steep slopes and significant relief. Now, I didn't include relief here in the definition because relief is just a measure of the total elevation difference from the high point to the low point, right? So mountains are pretty high, right? High elevations, and the foothills, the base of the mountains, are really low. That gives you a high relief or a significant relief, often formed by tectonic uplift, folding, or faulting. So sometimes rock masses, right, you have converging of plates, right? That's your uplifting forces. Plateaus, on the other hand, areas of elevated flat land with horizontal rock layers. So elevated, not as high as mountains, right? This might be a moderate relief, not a significant relief. All right, so you do have very sharp, steep sides, and usually you have a lot of plateaus in southwestern portion of the United States, where there's not too much weathering and erosion happening today. Typically formed by uplift and lava flows. Last one is your plains. That's your low elevations. We live on the plain here on the island. Extensive areas of low elevation and gentle relief. So between your highest point and your lowest point, in terms of elevations on plains, not too much of a difference, or barely a difference in certain areas. Right, that's why it says gentle relief, usually formed by long-term deposition of sediments by rivers, wind, or glaciers. All right, here's an example of your page, I believe it's page 10 of your reference table. Could be wrong. All right, but this is your landscapes. All right, let's go with the first one, Atlantic Coastal Plain. All right, so I live out here in Suffolk County. All right, and then there's Queens County here, and we're in the Atlantic Coastal Plain. Going up further north, we have the Manhattan Prong, which is the extension of some of the mountainous and highlands landscapes. We have a lot of Manhattan schist that is outlining Manhattan. There's the Fordham Gneiss, which is a part of the Bronx. Right, and there's also a lot of marble rock, which is the heating and pressurizing rock of limestone or dolostone. All right, from there we have an extension of the Manhattan Prong in the Hudson Highlands. Right, these dashed lines here symbolize a landscape region or boundary. And then from there it kind of goes into the Taconic Mountains, where it's shared between New York State and Connecticut, Massachusetts, and Vermont. Right, those are the three states that border New York State on the eastern side. Other high elevations, we have the Adirondack Mountains, which is part of the Greenville orogeny. Greenville orogeny is on your reference table. It's on page number 7. All right, your Greenville orogeny is part of your Proterozoic eon, under the Precambrian supereon. The other portion that's it for the high ones with the high relief. Moderate relief or your plateaus. We have 3 landscapes for the plateaus. We have the Appalachian Plateau Province. We have the uplands, Allegheny Plateau. We have the Tug Hill Plateau. Right, again, elevated horizontal rock, right, that has been uplifted. And we have the Catskills, which is a part of the Allegheny Plateau. The Catskills is where a lot of you might go skiing in the wintertime. One resort that comes to mind is Belair. Belair is a great resort in the Catskills. And I'm going up to the mountains, but you're not really going in the mountains. You're going in a weathered down plateau, basically. And you may have these plateaus that's been weathered down, and it might give you some sharp peaks at the surface, at the peaks of the areas of these so-called mountains, but they're really weathered down plateaus. All right, last ones are going to be your low areas, right? We have the Erie, Ontario lowlands. We have the St. Lawrence Valley province. Right now, valleys are areas of low areas between two peaks, right? So we have the St. Lawrence Valley province. And if you take a look here, it's between the Adirondack and the Greenville province highlands. We have the Champlain lowlands shared between New York State and Vermont. All right, and that's Lake Champlain here, the lighted portion of this map. The Hudson River Valley, that's connected to the Champlain lowlands. The Hudson River Valley is home to the state capital of New York called Albany. And we have the Valley and Ridge province. It's also connected to this. Now, the Valley and Ridge, right? Ridges are high points, valleys are low points. All right, this is a good example of some of the landscapes in New York State. We also have the extension here. We have the Mohawk River Valley going across. That's also a low elevation. All right, great example here of a picture. Right, we have mountainous landscapes, high relief. We have a peak in the foothills of the mountain. We have our plateaus. All right, kind of hard to see the horizontal rock, but this landmass has been uplifted and will give you nice sharp cliffs all around. And if you have the bedrock exposed at these cliffs, you can definitely see the horizontal layering of it. Last one is your plain. Right, your plains are your very lowlands areas, very low relief or gentle relief. All right, so great example of this is the Grand Canyon. All right, in these pictures here, we can definitely see this is plateaus. We have the Colorado River that runs right through it, and all these rock layers are all nice and horizontal. They all kind of like look connected to each other, and they have been all broken down by this flowing water. That's All right, next we have constructive forces. We have constructional forces we have tectonic uplift. Right, when two plates come together, one plate must subduct and one plate will override or be uplifted. Forms mountains and plateaus. Right, that's constructional, building up. Volcanic activity, also building up, creates new landforms. Island arcs. We have domes, which is going to be very high viscous material. And usually your domes are almost like your supervolcanoes waiting to burst. Deposition is another constructional force where you deposit sediments and building up. Rivers can do this, glaciers can do this, wind can do this, right? Forming deltas for running water, sand dunes for wind, and moraines with glaciers, right? And there's definitely more depositional features for all three of these. Floodplain development. Sediment from rivers builds up fertile land, right? So floodplains, we're looking at areas of land that can collect an overflow of water, right? If it overflows its channel, it can send all that eroded deposition in all different areas, right? It can add more nutrients to the soil. Last one, coral reef growth. We have coral skeletons accumulate and form land masses. All right, next we have destructive forces include, we have one, weathering, mechanical and chemical breakdown of rock. Right, if you're going to break it down, of course, it's going to have to get smaller in size. And then what goes along with weathering is erosion, right? Movement of sediments by water, wind, ice, and gravity. Gravity will always pull things down. Mass movements, landslides, rock falls, etc. The only thing I'm missing here, we have falls, slides, and the etc. can be some sort of flow, like maybe a mud flow. Right, that's always going to bring materials downhill, right? And the lowest part it's going to go to is the oceans, right? Your basins. Glacial erosion, U-shaped valleys, and striations. All right, so U-shaped valleys, right? The glacier is going to scour out the base and the sides of these valleys. Earthquakes. Earthquakes can fracture and lower land surfaces. Earthquakes can fracture and break apart the rock. Breaking apart can eventually be easy enough to get eroded away. And we think back to our lesson on earthquakes. We have three main types of faults. We have normal, reverse, and strike slip. Normal and reverse, right? For those two, we have at least one block moving down. Volcanic eruptions on this side being destructive would be big explosions. So like I was mentioned to you before, the dome-shaped magma below the surface, that's almost like your supervolcanoes waiting to explode, very viscous material. If that does explode, right, violent explosions that can destroy the land and reshape the terrain. Last one, human activity. We have mining, right? Taking away materials from the earth. So we have to, that's a breaking down process that humans can make. Deforestation. Deforestation can help with the erosion, right? We remove trees and root systems, right, more susceptible to eroding. And construction accelerate erosion, right? Construction, you have to clear the land and you're exposing soils and sediments to the weathering process. All right, last one, interactions. All right, dynamic balance. Landscapes are shaped by both forces at the same time. All right, so example here, a river can deposit sediment in a delta, constructive force, while also eroding its banks. Eroding, destructive. All right, that concludes this lesson. And try and answer some questions at the end. Thank you.